Good afternoon to all the participants, students, faculty to this webinar on the commemorating the Hiroshima Nagasaki Day. First of all, let me take this opportunity to thank Principal Sir Tirupaniam Sir and HOD of Physics Department Murthy Garu for giving me this opportunity to present what I know about nuclear energy. So, myself, KV Ganesh Kumar, Assistant Professor of Physics in DRG Government College, I hope the screen is visible to all. Now,
Yes, sir. It's visible, sir.
as you can see, the title of my presentation is Nuclear Energy, which is the creator and the destroyer. The title itself gives you a panoramic tone of my presentation. My presentation will be devoid of any mathematical relationships and all the deeper scientific insights. I would like to give you a panoramic scientific perception of the prospects of nuclear energy and what is the positive side of the nuclear energy also. From the title, what you can understand is that, for example, if you take the coronavirus disease, COVID-19, when we hear the term COVID-19, generally we go in a negative approach. That means COVID-19 is a dangerous disease which has a high mortality rate when compared to the seasonal flu. So many people are, thousands of people are lakhs of people are being affected and thousands are could not survive the disease. So when we think, similar to the fact that when we think of the term COVID-19 in a negative way, with due respect to the sufferings that we are facing in the form of the home isolation, all these things, without going to the college and without having the opportunity to teach to students all these things, there is a positive side to it also. You might also know that you might have read many articles in various newspapers that due to the coronavirus pandemic, what many nations have done and are doing continuously till now is that they are forcing lockdown. Due to this lockdown, the pollution levels have mitigated drastically. So, what in another perspective, what I think is that the coronavirus has given the Mother Nature an opportunity to heal itself. As we know, Mother Nature has a wonderful ability to heal itself. For example, the formation of cyclones, typhoon, all these things, they are an attempt made by Mother Nature to heal itself. Similarly, the coronavirus also, it has given us many hints that how we should live to protect the Mother Nature for the ensuing generations also. So, in the same manner, as Rajeshwari Madam nicely introduced in the opening, when we hear the term nuclear energy, generally we think of one thing that comes to our mind is that the Hiroshima Nagasaki bombing, because arguably that's right also. In that devastating incident, lakhs of people have died, and many people are still suffering. We can say, for example, if you ask me what is my API score last year and what is the vaccine that is given to my baby's 3-year child, I cannot remember. But even after 75 years, such is the physical damage and the psychological stress that has inculcated the Hiroshima bombing, that we are still observing this Hiroshima bombing and we are still trying to spread the message that science is always for good. It is our wisdom that should enlighten us and that we should not use it for destructive purpose. So in the same manner, so I would like to bring another dimension of nuclear energy, the creator part also, not the destroyer part. We are all familiar with the destroyer part. So you can see here, energy. The term itself is fascinating. Everything that we do revolves around energy. For example, for organizing this webinar, we are using lots of kilowatts of energy, isn't it? When you consume something, a food, something like that, the chemical energy in the food gets converted into mechanical energy. For example, in this webinar, the electrical energy is being converted to light energy and the sound energy and all these things. So our life revolves around energy itself. The statement which you can see here, energy is the currency of existence. This single statement is enough to signify
Sorry to
the
interrupt you,
goal of energy.
Ganesh, sorry to interrupt you.
Sir.
So can you maximize the slide? F5, press F5. F5.
Yes, sir, I know, sir.
Okay.
Okay, sir.
Okay.
The statement is the energy is the currency of existence. That single statement is enough to give an idea about the importance of energy in our lives. You have to deeply understand this sentence, currency of existence. What it means is that if something exists in the universe, it must have energy. Anything that exists must have energy. If I say that I exist, I have to prove that I have energy. On a funny note or on a lighter note, if you say that God exists, you have to prove that God has energy. Such is the fundamental role of energy in our lives and in the evolution of universe itself. So it is the currency of existence. If something doesn't have an energy, something doesn't have energy, it means that it doesn't exist. For example, the mouse that I am holding in my hand does have energy in the form of mass. So energy is the currency of existence. Moreover, as we all know, energy triggers the economic and social development of a country. For example, if you see in America, the per capita energy consumption is 10 times the energy consumption in India. So what you can understand is that in countries where the energy consumption or energy production is more, obviously those countries are economically, they are much more developed than the other countries which have lower energy consumption. So energy is like a parameter for the economic status of a country or a region and something like that. For example, if you are applying for a ration card, what the authorities scrutinize is that they ask for the electricity bill of the previous 3 months. Why do they ask that? Because the electricity bill is a measure of the consumption of electricity in the house. The consumption of electricity, the consumption of energy is a measure of your economic status. So, energy has a huge role to play in our lives. Those countries which have natural resources, the several energy resources like coal, oil, natural gas reserves, those countries which have such high reserves of those coal, oil, natural gas, they are developing much more rapidly those countries than those countries which doesn't have that much of these energy resources. So that is the significance of energy. Every process that we see around us is simply a conversion of energy of one form into another. So, such is the fundamental role played by energy in our lives. Without energy, we are just powerless. So, with a brief introduction of energy, I move on to the next slide. So, what is nuclear energy? As the name rightly suggests, as we know that this being an interdisciplinary dinner, I would like to express my ideas in a lighter scientific note. So, to even to the common man, those who are belong to the history background also, they may understand these topics. Nuclear, as we know, the smallest building block everybody thought was the atom. The very name was that the atom came from the name that the Greek atomos. Atomos means uncuttable. So everybody thought that atom was the smallest building block, but later science is nothing but the development. It is the purity. It goes on. There is only one religion in the world that criticizes itself and makes progress. That is science. I am proud to say that. And the students also should, those who are studying science, they have that passion to, while studying science subjects, it is the only religion that criticizes itself and that purifies itself and goes ahead. That's the only religion, science, that I always find inspiring about science. So later scientists discovered that atom is indeed cuttable and it consists of a dense core called nucleus around which electrons circulate. So the dense core, which is a very small region, and it contains almost 99.99% of the mass of the atom, is named as nucleus. So nuclear energy is nothing but the energy which has been obtained from the nucleus. How you obtain the energy? Then we may have different processes. For example, nuclear fission, nuclear fusion, all these processes. So fundamentally speaking, nuclear energy is the energy which has been obtained from the nucleus. So one thing we should make note of is that here you can see in the photo, in the picture, Albert Einstein explained the equation E is equal to mc square. As we all know that this is one of the most popular and famous equations of all time. Even a non-science student, a student of history background or a commerce background, know this equation. Such is the popular effect of this equation. As this equation tells that, as you know that in the equation, E is the energy, M is the mass, and C is the speed of light. The only constant thing in the universe. Everything is changing except the speed of light. So what this equation tells you is that mass and energy, everybody thought that before Einstein, if you, such is the fundamental role of Albert Einstein, fundamental effect of Albert Einstein on the scientific realm is that, for example, if you divide time before Christ and after death, something BC AD, in the same manner, if you want to divide the scientific era, you have to divide it before Einstein and after Einstein. Such is the tremendous impact he has on the scientific discoveries. So he has unified so many things. Unification has a lot of beauty, isn't it? If you ask somebody what is the most memorable day in your life, most people would say it is a marriage day because it is the unification of hearts. Similarly, Einstein has made so many unifications. The attempt of Einstein to unify many things is something that is always fascinating. One such unification is the unification of mass and energy. Of course, that unification is already there before the mankind has evolved also, but he has identified and he has found that they have that inbuilt unity. So what this equation tells you is that I will later tell you why I am explaining this equation before explaining the nuclear energy. This equation has a role to play in the explanation of nuclear energy. M is the mass and E is the energy. What this equation tells you simply is that mass and energy, they are not different entities, they are interconvertible. Mass can be converted into energy and energy can be converted into matter. So as a consequence of this is that when you use nuclear fission or a nuclear fusion, what happens is that, for example, if you take nuclear fission, two smaller nuclei fuse together to form a large nucleus. For example, A and B are the smaller nuclei, and C is the nucleus which is formed when A and B combine. For example, the masses of A and B, let it be 1 gram and 1 gram, hypothetically, then the mass of the combined nucleus C should be 2 grams. It will never be 2 grams. 1 plus 1 mathematically equal to 2, but as per physics, it is not 2. Mathematics is quite different from physics. In mathematics, you can say C plus C is equal to 2C, but in physics, you say that C plus C is equal to C. C is something which is not it is very constant and it does not change. So what happens in the nuclear fusion reaction is that so the mass of the combined nucleus C should be 2, but it will never be 2, as I told earlier. It will be some fraction less than 2. That small fraction, the deficit of mass, will be converted into energy. If you don't take into account the mass energy equivalence and the fact that mass gets converted into energy, you might end up scratching your head. What happens to the mass? It is a law of conservation of mass. So what happened to this mass? The mass of the compound nucleus C should be 1 plus 1 2, but you have to identify the fact that the mass energy equivalence is also one of the fundamental principles of nature. It is as fundamental as you can get. The evolution of the universe itself stems from this equation, E is equal to mc square. So what happens, as I told earlier, the mass of the combined nucleus will be a fraction less than the sum of the masses of the two nuclei. Thereby, that missing mass gets converted into energy. As we know, the value of the light speed, c, is 3 into 10 power 8. 3 into 10 power 8 is a very large value, as you know. So even the mass of the, if the mass of the particle is small, then if you multiply it with c square, then you will end up with a very large number E. You can find a video in YouTube with Einstein explaining in his own words the equivalence of mass and energy. What he says is that mass and energy, they are not different. They are interconvertible. Even a small amount of matter contains a very large amount of energy. So in nuclear energy production processes, what happens is the mass gets converted into energy. When mass gets converted into energy, even a small amount of matter will give you very large amount of energy. As many of you might have known that the Hiroshima incident, when the Americans dropped the little boy on Hiroshima, and subsequently after 3 days, they dropped the fat man also. The devastation that has been created has been discussed till now also. So you might expect that tremendous amount of energy might have been released. It is a nuclear bomb. So the energy which has been produced is from nucleus itself. It is a nuclear energy. So why such tremendous amount of energy is released? That is the answer which has been given just now. Even the mass when mass gets converted into energy, even when the mass is small, you will have a lot of energy. In that process, you will produce a lot of energy. Surprisingly, as many people might know that how much amount of mass gets converted into energy in that Hiroshima bomb is about not even a gram. It is almost about half of gram. So 0.5 grams of mass when gets converted into energy, that's what happened. Even after 75 years, here so many academicians and so many participants are gathered here organizing a webinar discussing the impact of Hiroshima bombing. Just 0.5 grams of mass is responsible for the entire destruction. Such is the power of this equation. Such is the power of mass energy equivalence. So that nuclear energy, it is harnessed from nucleus through the principle of mass energy equivalence. Yesterday, 2 3 days ago, we heard that in Lebanon, the capital of Lebanon, Beirut, there is an explosion. In that explosion, that one also a very devastating explosion. So many people have died, but you cannot compare that explosion to the Hiroshima bombing. You can never compare it because basically energy kills, isn't it? When you, on a lighter note, when somebody shoots you, uh, we may file a case against the person who shot us, but it is the kinetic energy of the bullet that is the killer in the physics perspective. It is the kinetic energy that killed us. If the bullet is not in the gun, you can handle it. You can hold it in your hand. It is the kinetic energy. So energy kills. So in the explosions, the casualties of the so many injuries, why they happen is that it is due to the energy. So there is a fundamentally different mechanism here in nuclear bombs. In Beirut blasting, it's an ordinary bomb, some large amount of explosives are used, but in that explosion, energy of one form gets converted into another form. So it is conversion of energy into energy also. But in nuclear bombs, in Hiroshima bombing or Nagasaki bombing, it is the conversion of mass into energy, which, as I told earlier, produces a vast amount of energy even with a small amount of mass. So the reason why I'm saying laying stress on is the fact that, for example, I will give you an analogy. If you have a lot of wealth, so much wealth, like Mukesh Ambani or somebody, you take a celebrity, uh, you invest that wealth in many things. Generally, we some purchase some plots, or so invest in houses, or we sometimes invest in gold. So to save or to protect our money, we invest in something. Nature also has discovered a mechanism to store its energy. That is nothing but mass. It is the most effective way to store energy. It is the densest form of energy, you can say. Mass is the densest form of energy. For example, if you have a lot of money, for example, if you want to store 10 lakh rupees, it will occupy a large place, isn't it? For example, if you purchase gold of 10 lakhs value, that doesn't occupy that much place. So what happens is, it is a much safer option, a better option to save that money. In the same manner, nature during the evolution, it has so much of energy. So nature has devised a mechanism to store its energy in the form of mass. So this is the underlying statement here. The bottom line here is that why nuclear bombs are so dangerous is the fact that in nuclear bombing, the basic mechanism of production of energy is the conversion of mass into energy, which obviously triggers production of tremendous amount of energy due to this equivalence of mass and energy, which Einstein discovered. So I hope I am clear. This nuclear energy is a basically different process of producing energy. Move on to the next slide. As in the title, I have mentioned that nuclear energy is the creator and the destroyer also. Why I have tagged that word that it is the creator? For example, in astronomy, you might have known that as per the best theory that we have right now, universe evolved or rather born from an incident called Big Bang, isn't it? It happened very long time ago. Don't even know when does it happen because space, time, everything started from that point. You cannot ask the question that when did Big Bang took place. That question has no meaning because time itself started from that incident. that event, the event of Big Bang. So when the Big Bang occurred, um, uh, what happened is the universe expanded. With it, the space, time, and everything also expanded. So it goes on. If it is expanded like that, you and I and life like our by ourselves would not have existed. What happened is that due to gravity, in some area, nebulae formed. Nebulae, and these nebulae also due to the gravitational attraction in some parts, stars were beginning to form. Due to this production, due to the formation of stars, what happened is star is something that is self-illuminating, as you know that. So where does the star gets its energy from? The reason why I'm talking about stars when it comes to nuclear energy is that you can see in the line, the origin of life in the universe is made possible only by the nuclear energy produced in star through nuclear fission. You can ask me, you can contradict why we are talking about the sun, the production of energy in sun, when you talk about the origin of life. As we know that we are not products of earth, we are products of sun. Earth itself is also produced from sun, and moreover, we are at the start of the universe. There is only hydrogen, predominantly 19% of hydrogen and some part of helium, rather. But we are not made of hydrogen and helium. We are primarily made of carbon, nitrogen, oxygen. Such heavier elements constitute us. So, where does these heavier elements come from? So, what I want to tell you is that the necessary ingredients to form for the birth of life, the oxygen, nitrogen, these heavier elements, where did they produce? They are produced in the deepest chambers of sun. So how the factory sun works? Sun works on basing on the principle of nuclear fusion. Again, here the nuclear energy. So what happens is in sun you will have hydrogen and helium. These nuclei fuse together, as I told earlier, in nuclear fusion reaction, and hydrogen and helium fuse together, they form lithium, and lithium again in turn fuses with helium, producing some heavier element. In the same manner, you will end up having some heavier elements. These heavier elements are stored inside the sun. So the seeds which are necessary are required for you and I to form. They are formed in the deepest chambers of the sun, and that is made possible only by the formation of stars and indirectly by the production of nuclear energy. We do Surya Namaskara in the mornings. Many spiritual people do Surya Namaskara because sun is the provider of energy. Where does the sun gets its energy from? The sun, even the sun, which is responsible for the origin of life in the universe, gets its energy from nuclear energy. It is the nuclear energy, it's nothing more than that. So you can understand is that the mass energy equivalence or conversion of mass into energy is the fundamental mechanism with which nature produces energy. So the origin of life in the universe is also produced due to nuclear energy. So this is the positive side of nuclear energy. You can clearly understand. After listening to this, you can clearly, even though we have a very negative approach, even though of course we are using nuclear energy for power production, also many nuclear reactors are still there. But generally, if somebody says that a nuclear reactor is going to be built in the city, many people would oppose. If you conduct a survey, 90% of the people would say that it would be hazardous, some radiation leak will be there and will be dangerous for the people living in that area. But nuclear energy, on the other side, it is responsible for the origin of life. It is something that is responsible, and that is something that triggered the evolution of life in the universe. So this is the positive side of nuclear energy. As I told earlier, it is a fundamental mechanism employed by Mother Nature to harness energy. Surprisingly, I would like to tell you one thing here. As I told earlier, the Big Bang is the event that started everything. After that, everything expanded, and in some places, stars have born, and the stars, due to the nuclear energy which has been produced, and all these things happened. You might have some people might have known that the total energy of the universe is zero, approximately zero. The universe is a free lunch. You can feel it. The universe is a free lunch. So where does this energy come from? This energy comes from a small quantum fluctuation at the Big Bang event. This quantum fluctuation, some small quantity of energy of the order of Planck's constant emanated, and this energy gets converted into mass, some anti-particle pairs have been produced, and the universe that we are seeing, the vast universe that we are seeing now, is a result of this conversion of mass into energy, and later the formation of stars, which in turn is due to the nuclear energy and all these things. So nuclear energy has played a pivotal role in the formation of stars, and in turn in the formation or in the origin of human beings like us. That is one thing I would like to stress upon. As we can see, the energy consumption of humanity has increased dramatically. You can see the graph here from in chronologically in 1820, the world energy consumption is very small. 1820, 1840, as you go forward in the timeline, you can see in after 2000, the graph almost, excuse me, the graph almost rose vertically. So along with the development, in parallel to the technological development, the consumption of energy also increased rapidly. How do you meet the energy requirement? For example, you are burning oil, coal, natural gas, and recently you are turning to renewables also. But all these energy generation process, for example, if you take oil, coal, natural gas, even the renewables also, solar, wind, and all the geothermal energy, and all these things they are they are simply different forms of solar energy, isn't it? All these forms, coal, oil, natural gas, and all these things they are one of the different forms of solar energy. But the amount of energy that we can produce from these sources is very small. I can say this because, um, for example, if you go back in the Hiroshima bombing, how much of mass gets converted into energy? Only 0.5 grams of mass got converted into energy. With 0.5 grams of mass, we have that tremendous amount of energy. Then, if you can, if you can address the safety issues as well as the develop a mechanism for or exploiting this nuclear energy, you will clearly overcome the energy scarcity, and we will have a lot of energy available. So nuclear energy has that potential to address all the energy needs here. I'm using very cautioning words here. Nuclear energy, of course, it has some side effects also, some safety issues, but from a purely scientific point of view, if we can address the safety issues and all these things, surely nuclear energy has that inbuilt potential, because the basic uh, energy production process, that is the conversion of mass into energy, has a lot of potential. Even with a small amount of matter, you can produce a large amount of energy. So all we have to do is that we have to devise some safer methods and some process of producing nuclear energy, advanced methods. All these methods are required to produce the energy, to meet the energy demands of the future generation. Has enormous potential to, as you can see in the slide here, nuclear energy has enormous potential to address the growing energy needs of the modern civilization. So on the other side of the coin is that to meet the increasing energy requirement, we are burning more oil, more coal, and more natural gas. Of course, some part of renewables is there. Still, the nuclear energy supplies almost 10% of world's electricity. That is a small amount. What we can do is that with devising some safer methods, we can enhance the nuclear power percentage, so that we can mitigate the use of these non-renewables like oil, coal, natural gas. When you mitigate the use of these conventional resources, obviously it leads to some, it will address the environmental concerns due to the carbon emissions and all these things. So uh, if we can if we can safely explore or exploit the nuclear energy, it will do a lot of good for us. It is the cleanest energy that we can produce. Even with renewables also, you will have some disadvantages, like they are intermittent. For example, wind energy, solar energy, they are intermittent. They have huge capital investment, all these things. Apart from this, with proper developments in science, nuclear energy has the potential to surpass all these achievements and produce a lot of energy modern man needs. So this is the creator part. So till now, what we have discussed is that nuclear energy on a positive side. It is that energy, it is the nuclear energy that is responsible for the formation of stars, and the formation of stars itself led to the production of heavier elements with which we are all made up of. So it has played a pivotal role in the evolution of life also. But in the second thing is that it has the potential to address our energy needs also. That is the positive side of nuclear energy. Now, as you can see here, Little Boy is the name of the atom bomb. It is the code name which is given to the atom bomb which is dropped on Hiroshima on 1945 August 6th. You can see the diagram photos here also. Fat Man is the name of the atom bomb dropped on Nagasaki after 3 days. Um, this is the negative side. Moving on to the next slide, you can see in the picture why nuclear energy is destroyed. It is the nuclear energy that is responsible for the devastation that we are seeing in the picture. Almost it is like a graveyard. One more photo. These photos are taken after the explosion of the comparison. You can see Hiroshima city before the blast and after the blast. You can see a wide contrast between these two photos. And it is even surprising to note that, as I told earlier, only just 0.5 grams of mass is responsible for this entire destruction that you are seeing on your monitors. Such is the potential of nuclear energy. This is the present photo of Hiroshima. Even after that devastation, they have managed to revive their economy, and they are presently doing good. Future of nuclear energy. I would like to touch upon the future of nuclear energy. Nuclear energy, as we can say, it is the trade-off between the safety and energy security. I can see many advocates, many people who are advocating this that due to the nuclear disasters that have been happening recently, nuclear energy is something that should be production of nuclear energy should be mitigated due to the safety concerns. But as I told earlier, the energy security, the exponentially increasing energy requirement can be met only if if we produce the nuclear energy. Nuclear energy provides, as I told earlier, 10% of the world's electricity, and that will increase in future also, even with small opposition there. It is the second largest source of low carbon electricity. That is the advantage of nuclear energy. With nuclear energy, it is the with uranium, as long as the uranium reserves are there. Approximately, if you at the present rate of consumption, uranium reserves will be there for almost 200 years from now. So you don't have any scarcity of coal, oil, natural gas like that. You have lot of uranium reserves, so you can produce nuclear energy continuously. Only thing is that you have to address the safety issues. It is the second largest of low carbon electricity. It is the fastest growing energy resource. In this photo, you can see the consumption of energy. It is the future of nuclear energy. The nuclear energy, how the use of nuclear energy has increased chronologically with time. Total energy consumption, total world energy consumption. Still, we are these stats are from 2019. You can say 38% is from coal, 22% is from gas, and then hydro. You can see here 10.2% of the global energy comes from nuclear. So it has that. It is the second largest low carbon producing energy source. I would like to conclude with this quotation by Albert Einstein. Science always offers good for all us. As I told earlier, it is the wisdom of the humanity to use science for only constructive purpose. It is not for destructive purpose. It is a famous quotation by Albert Einstein. I don't know with what weapons. I know with what weapons World War III will be fought, but World War IV will be fought with sticks and stones. You can clearly understand if World War III would have happens, we don't know with what weapons it would happen. Some bio weapons are there, some anthrax like viruses are there. But World War IV, if it happens, since every country has a nuclear bomb, after bombing of Hiroshima, we have seen what happened. In the same manner, if every country uses a nuclear bomb in World War III, then nothing will be left. Then World War IV, even if after that we want to fight, World War IV will be fought with sticks and stones. This is the message that Albert Einstein gave to us. So, my presentation is all about the role of science in transforming the society. Science, as continuously stressing, always does good to us. Science is nothing but it is an incessant pursuit to understand Mother Nature. In that pursuit, we discover some principles, and we have to make use of principles for the good of the society. For example, if we go on manufacturing nuclear bombs and all these things, then it will be devastation only. So uh, we have to use science for good only. That is the message Albert Einstein would like to convey this. Thank you, sir. Thank you. I would like to answer some queries if participants are asking. I open the conference for any queries.
Yeah. Participants can unmute themselves and ask queries. Ganesh, you can also unmute yourself. You may have been muted. Those who want to ask queries, who want to clear your doubts clarified, can unmute yourself. You
Sir,
can.
can I, sir?
Yeah,
Sir,
yeah.
can I ask a question, sir?
Yeah.
Sure, madam.
Sir, what are the possibilities of shifting from carbon-based fuel economy to hydrogen-based fuel economy, sir?
Sure, madam. Actually, we are in the process of doing so, madam. Many
Yes.
countries are resorting to the renewable energies now. As you can see, the government also providing subsidies for the establishment of solar plants and wind plants and all these things. All these attempts are intended to mitigate the use of these carbon fuels like coal, oil, natural gas, and encourage the low carbon resources like coal and the wind, solar, and the nuclear also. So we are moving in the direction, madam. But when can we achieve that? It happens very slowly, madam. Just like the growth of a plant, the transition takes place always slowly. You can never say from sunset to sunrise, the transition takes place very slowly. In the same manner, the shift of paradigm from a non-renewable energy sources to renewable energy sources, the transition takes place very slowly. We have to wait, and fortunately, we are in the direction, madam.
Sir, meanwhile, we have to combat with environmental degradation, sir.
Yes, madam. That environmental degradation is a consequence of the use of, as we know,
Carbon-based.
the carbon-based fuels. My
Yes.
presentation also advocates the fact that if we can devise safer methods for the production of nuclear energy, addressing all these issues, nuclear energy is one of the cleanest energy resources. If we can address the radiation leak and all these problems, that is the cleanest energy source, not just the quality, it is the quantity, how much energy it can produce. That's simply it is out of your imagination. It can produce, it has the potential to produce a lot of energy, provided the other issues are addressed.
Thank you, sir. Thank you very much.
One thing I would like to add is that,
Sir.
for example, you might have seen in many films, aliens. We are located in some science fiction movies from far planets or far different solar systems. They come to us, they visit us.
Flying saucers.
What is the fuel that they use? They use a process called annihilation. Annihilation is a process where you combine matter with antimatter, which produces a lot of energy. So, from physics point
Annihilation
of
it is
view,
called.
production of energy using the mass energy convergence principle is fundamentally different. It has a lot of potential. Nuclear energy is one such mechanism which exploits that conversion of mass into energy. That's what I would like to stress.
Thank you, sir. Thank you very much.
Chernobyl and Japan incidents are developed by causing human errors.
Yes, sir.
So people are worried to start any nuclear reactor. They want to not to use nuclear energy.
Right.
So they are hesitating to start a project in their place.
Right.
Because ours is a densely populated country,
Yes,
and
sir.
establishment of a nuclear power plant involves what we call evacuation of people from their respective places. And they're
during
not
the
properly accommodated somewhere else also. That's what we have seen in Narmada. That is because of which Narmada Bachao Andolan has come up.
Yes, madam.
These are all the practical difficulties
Madam,
that we encounter.
Madam, you will have number of practical difficulties when we are trying to do something. For example, we are planning to give video lectures to students from tomorrow onwards as per the in compliance to the instructions of Honorable Commissioner. You might have come across a lot of problems. For example, students might have 1 GB data per day. After the completion of 1 hour of class, their data might get expired and they go offline. There may be various issues. Even in the hydro electricity production also, the environment also, they have a lot of opposition. In the same manner also, for nuclear energy, there may be a lot of opposition from the public perception. But from a purely scientific point of view, I'm only exploring the potential of nuclear energy.
Yes, sir. But
That's why I
is it suitable?
keep on stressing the point that it is in the hands of the scientists to devise safer methods and use a much more superior technology so that we can extract that potential. It has the potential to surpass all the energy needs. There may be opposition, madam, and the opposition may be real also, but the thing is that we have to overcome through incessant efforts.
And convincing way and taking precautionary measures.
They may be convinced only with proper development, sir. Without the political dialogue, do not do any good. With scientific development, they may be able to understand the fact. For example, manufacturing a vaccine. For example, if you take genetic engineering, there may be many people who oppose that branch of science, genetic engineering, that is not ethical and all these things. So again, the same discussion comes here. Science is always for good. Only thing is that we have to employ our wisdom to use it for construct, not for destruction.
Good or bad.
Any more queries from participant?
Sir.
The participants can unmute themselves and ask your questions. Any more questions?
Aditya Garu, you can unmute yourself.
The participants who wish to ask questions can unmute themselves. Just raise your hand so that we can unmute you. Raise your hand, those who wish to interact with the research person. Simply raise your hand so that we can see you and unmute you. Okay, I don't think there are any questions. Shall we go ahead with the second speech?
Okay, sir. Okay, sir.
Thank you, Ganesh. You have really delivered a wonderful lecture. Really, some of the facts we don't know about nuclear energy. Really, you have given good insights into nuclear energy, and you have related that nuclear energy with life, origin of life. That is really a fascinating concept. Thanks so much. I request Akala Rajeshwari. Hello.
Sir. Madam. Yes, sir.
To appreciate, congratulate him.
Yeah, thank you very much, sir. Thank you very much for your wonderful presentation on nuclear energy as creator as well as destroyer. And also today I came to know about many facts, and even an art student like me can understand science well. And that's what you proved today with the help of a good teacher.